Hello students, this is a question from JEE Main 2019. A smooth wire of length 2 pi r is bent into a circle and kept in a vertical plane. That means this circular wire is having a radius r, that's why its circumference is 2 pi r, total length is 2 pi r, so radius r. And this circular wire is rotating about this vertical diameter AB with angular velocity omega. So a bead can slide smoothly on the wire. Here is the bead. A bead is nothing but a kind of tiny spherical shaped object in which there is a hole inside through which a wire can pass easily like this, and the bead can slide on the wire, okay, something like this. So a bead can slide smoothly on the wire, means no friction. When the circle is rotating with angular speed omega about the vertical diameter AB as shown in the figure, the bead is at rest with respect to the circular ring at position P as shown. That means this particle P will remain here only, it won't fall down because the reason is that as it rotates in a circle, see here, this particle P over here, and it will rotate along this circle, this small circle of radius r by 2 as shown here, radius r by 2. Then what is the omega square value? So first of all, this the circle is rotating in a vertical plane with angular velocity omega. So even this particle is also rotating in a horizontal circle with angular velocity omega. And due to this circular motion, the particle experiences an outward centrifugal force. You know that centrifugal force formula is given by F is equal to m omega square r. Basically here r is r by 2, because it is said in the question that this radius is r by 2. This is radius r by 2. And the radius r of this circle is this one. We can draw this line, this hypotenuse line, this is radius r. Suppose this radius makes angle theta with the vertical. Now the particle also experiences downward force mg, and also a normal reaction force perpendicular to the wire like this. This is the normal reaction N. Let us now resolve the normal reaction into horizontal and vertical components. So this is the vertical component, and here this is the horizontal component. Now look at the angle theta. Let me zoom in a little bit for more clarity. So the angle theta is made by this radius with the vertical. So this angle here, which we can say this is the alternate angle, theta should be equal. So the vertical component will be n cos theta, and horizontal component will be n sin theta. Again, a reminder that whenever we resolve a vector into components, let me explain this side, okay. Say this is a vector, and when you make its components, horizontal and vertical components, and suppose the angle theta is made with the vertical component, so the component that makes the angle theta will be cosine component, and the other one is the sine component. So this is the rule for making the components. Now after we have made the components, let us see, as the question says the particle remains under equilibrium, it stays at rest at that position. So we can say that the horizontal force must balance each other. That means the n sin theta must balance the rightward force. Leftward horizontal force, n sin theta should balance the rightward horizontal force, which is m omega square r by 2. Similarly, in the vertical direction, upward force n cos theta should balance the downward force mg. So we formed our equation 1 and 2. We have to find what is the value of omega square. What is omega square? So we can find the omega square from here. Let us divide both equations. Divide the equation 1 by 2. That means n sin theta divided by n cos theta. N sin theta divided by n cos theta will be equal to m omega square r by 2 and divided by mg. Okay. So from both sides, you can see normal cancels on the left side, mass cancel on the right side. Then we have sin theta by cos theta equal to tan theta. So tan theta is equal to omega square r by 2g. Okay, but what is the value of tan theta? Let's go back to the diagram. If you look at this triangle, let us color this triangle. Look at this yellow color triangle you can see here. In this right triangle, can we apply trigonometry? Yes, we can apply. As you can see, this angle theta, the opposite side of this angle theta is r by 2 and the hypotenuse is r. So that clearly means sin theta can be found from here. Sin theta is defined as opposite side by hypotenuse. So opposite side is r by 2, angle theta opposite side r by 2 and hypotenuse is equal to r. So we get sin theta equal to 1 by 2. Which clearly means that angle theta is 30 degrees. So coming back to our this, so we write tan 30 degrees equal to omega square r by 2g. The value of tan 30 is 1 by root 3. So 1 by root 3 is equal to omega square r by 2g. Therefore, omega square value is equal to 2g by root 3r, which is option B. B is the answer of the question. 2g by root 3r. That was asked in the question, value of omega square. I hope it is clear. Thank you.